This will be Thursday of week 1. So welcome back. Let's go ahead and get started. So this will be the third problem from this set of homework where we're looking at mean, median, and mode. Okay, so again, the first thing that I always want to do is start by putting the order. Anytime I have a set of data, I want to start by putting it in order from least to greatest. So I have a 2, 5, 9, 12, 15, 21, and 35. Okay, now let's start with the mode. And in this case, I have no numbers that repeat. So again, my mode is none. Again, not 0, because 0 is an actual number, and that would indicate that there is the most digits of 0, and we don't even have a single 0 here. Let's go ahead and go with the median. The median is going to be my middle number, so I'm going to start on the outside, count in, 1, 2, okay, right here. 12 is going to be my median. And then last but not least is the mean. Remember, your mean is also known as the average. You're going to total up these numbers and then divide by the total amount of digits. So I'm going to do just some very quick math. I've already added all these numbers together. So I added 2, 5, 9, 12, 15, 21, and 35. And when I did that, I got 99. Okay, and again, I didn't do that on a calculator. I did it by hand. Proof here. Okay, but I'm going to just not do that for the sake of keeping the video shorter. Now, there's a total of 1, 2, 3, 4, 5, 6, 7 digits. So I need to take this 99, I need to divide it by 7. 7 goes into 9 one time. 1 times 7 is 7. Drop down. 9 minus 7 is 2. Bring down my 9. 7 goes into 29 4 times. I'm going to go ahead and add my decimal here because I know that I am going to probably have some tenths place and hundredths place. 4 times 7th is 28. I'm going to go ahead and drop down again. 1. I'm going to add a 0 here because, again, if you add a 0 to the right of a decimal, it does not matter. It's not going to change the value. I'm left with 10. Bring up the 1 because 7 goes into 10 one time. And I'm going to stop here. And just round it to this place. So my mean is going to be 14.1. I could continue going, but in this case, if I did, it would be 14.14, and I would just round this down to 1. Let's go ahead and go over to this set where it says write an expression for each of the following. Less than, 14 less than P. When I see the words less than, those are flip around words, which means that I need to reverse the order of the digits. So P less than means to subtract 14. This is one that's very commonly missed with students because they want to do 14 minus P. But again, less than are flip around words. 7 increased by 4 times a number. Increased by means adding 4 times a number. So we're going to do 7 increased by 4 times a number. Okay, and there's a couple different ways that you could write that, because 4n could be written with parentheses or multiplication, but we're just going to write it like that because that's the most efficient way of writing. 2 times a number plus 5 squared. Let's start from left to right. 2 times the number, 2n plus 5 squared. Okay, very good. Those are some translations. Moving on to here, simplify what you know about combining like terms and distributive property. Hint, multiply to remove all the parentheses by using distributive property, then combine like terms. I have an awful lot of people that forget that step. They do distributive property great, and then they forget to combine. So we're going to start by multiplying 6 times each of the term within the parentheses. So I'm going to multiply 6 times 3y, which would be 18y. Then I'm going to take my 6 and multiply it by a positive 4, which would be plus 24. Now I'm going to distribute my 2 to the 2 terms within this parentheses. 2 times y is 2y. 2 multiplied by a negative 5, a negative and a positive when I multiply together becomes a negative term. Now, if you stop here, your answer will not be correct because it's already told me to combine like terms. I have a set of like terms, 2 sets of like terms. I have an 18y and a plus 2y. I always tell students to grab the sign that's in front of their term because that is extremely important, especially as we move into dealing with integers more frequently. You need to know if it's minus that term or plus that term. So if 18y plus 2y is going to be 20y. Next thing, I'm going to go ahead, I'm going to use circles to circle my constants. So I have a plus 24 and a minus 10. Different signs, subtract and take the sign of the larger. So this will be a plus 14. Let's go ahead and drop down to the next problem. Okay, this can't combine anything here, but I have distributive property right here. So I'm going to rewrite my first part of my expression. 4 times 2x is 8x. 4 times 2y is 8y. I have, again, a couple sets of like terms. I have x's, okay, and again, these are like terms because they have the same variable and the same exponent for that variable. So 3x and 8x are both positive, so they're going to be 11x, and then I have a plus y and a plus 8y. Remember, if I don't see a coefficient here, that's always assumed to be 1, so this is plus 9y. Okay, last but not least, we have this word problem. Clark ran around the track 3.5 times. If the distance around the track is 1/4 of a mile, how far did Clark run? So this is going to be a multiplication problem, but I need to have everything in the same format. This is in the format of a mixed number, and this is in the format of just a regular fraction. So I'm going to go ahead and I'm going to change this mixed number into an improper fraction. I'm going to do that by using reverse C. And remember, in reverse C, 2 times 3, and then add what's in the numerator. So 2 times 3 is 6, plus 1 is going to be 7 over 2. And I'm going to multiply that by 1/4. Now, we're going to go ahead and multiply across. 7 times 1 is 7. 2 times 4 is 8. So it's 7/8 of a mile. Now, one of the things that I always do, and even though I'm a math teacher, I always check myself, and I do that by saying, does this answer make sense? And sometimes students will do this before. They'll do estimating before. But it's a really good idea to think about, especially when you're dealing with measurements, distances, things like that, that you think, does this answer make sense? Okay, so he ran around the track 3.5 times. So that means he's almost 4 times. 1, 2, 3.5. Okay? If the distance around the track is 1/4 of a mile, how far did Clark run? So if each time he's running 1/4 of a mile, in order to run a full mile, he would run 4 laps. Right here, he ran 3.5 times, which lets me know that he's going to run almost a full mile, but not quite. When I look at my measurement here, this is almost a full mile, but not quite. So the likelihood is I've set my problem up correctly. So many students have difficulty when they are doing problems that are word problems with fractions. They're not sure if they add, multiply, subtract, divide. And so, again, I always check myself just to say, does this answer make sense? Because if you had done division, the number would have come out well above 1 mile. And so you would know, like, hey, that doesn't make sense. All right. Thanks so much.